Welcome to part 2 of Competency 12. In this video, we will work with similar triangles. Okay, before we begin, let's go over this table really quick involving scale factor, all right? Now, one thing that we need to remember, and it's illustrated for each column for just your length, which would be related to perimeter, your area, and then your volume. So let's look at the first column. What we need to remember is that we go either way. You can go from the smaller figure to the larger figure, or the larger figure to the smaller figure. And that's where the two different equations go into play. I need you to notice that over here, that x is with the smaller one, okay? Which is your unknown you're looking for, but yet on the next one, you can have X related with the larger one. So it just depends on what your problem is asking you to do. Okay, so in this situation, they've solved one. Well, what does this mean? Since the 6 is related to the 3, which is larger, it's larger value in relation to your K. Okay, so 3 would be your A and 2 would be your B. Okay, this means that this is 2, 2, and 2. Well, then when we go through the motions and we get the perimeter, which is K, of the smaller one, if you divide that out and you work with it, you find out that each side is 1 and 1/3. Okay. All right. It works out. You'd have to stop the video and get your calculator out, your pen and paper, and try to figure that out. Okay, now for the next one, let's look at what it's saying. This is area, so that's a different situation. So for area, you have to square your K. And it doesn't matter, your scale factor must be squared. And it doesn't matter, which way you're going. Now, sometimes when you have a problem that's quote unquote reversed, then you'd have to show the square root. And there's a problem coming up like that. Okay, so what is this saying? This is saying, if you look at our problem that is set up, this is saying that our known area would be the 5. And then which is the smaller one. And we're looking for the larger area, okay, because it's across from the 9. So that's 11.25. Okay. Now, I know I have digital issues with that every time I write on that, but doesn't matter. Okay. So then if you're looking at volume, I'm sure you figured out, it's cubic. A volume is 3 things multiplied together. You have base times the length, or you could say length times width times height. You're multiplying those 3 things together. And that's why we have a prism, and it's a rectangular prism, and you have 3 edges that you multiply together. Okay. Now, if you look, you're 8. Okay. If you're looking up here, how they set it up. So 2 to the 3rd is 8, and 8 is associated with 64. That tells me that the smaller box is 64. Well, and my technology is wanting to move that. And then my writing is not the best. So 64. I don't know if that's any better. So this tells me that our larger one is the 216. Okay. All right. So if you have to, or if you want to, I would take a screenshot of this. If you're not familiar with using these properties, it's very common. And you know what? I would be surprised if a test didn't have this on it. And I know for a fact that at least one question on the university practice tests I've taken a couple of them, this is 100% on there in some way. They're going to figure out a way to ask you this, and they'll ask you it in very strange words. So you might want to just snip this so you have it in your notes. Okay, let's move on. Number one, if triangle ACF is similar to triangle GLM and BC over GL is equal to 3 over 5, select all the other ratios that have a value of 3 over 5, meaning that they can be simplified to that. Okay, what are we really looking at? Okay, let's just say when a problem is written correctly or a teacher gives you something and it's actually written the way it should be. Okay, that means that we have this comparison. Okay, all right, look here. Our first one, that's our BC. Well, that's our numerator. And then they're saying the first two letters are actually the length of that triangle. So, okay, I am going to actually let's do the ink shapes and let's see if that works. I've tried that and it doesn't always work for me. See, it doesn't work for me. Well, you know, technology, it's got to work. Well, it says it's on. Let's see here. Well, oh, there it goes. Okay. Delay reaction. Okay. So let's say that that's going to be my smaller triangle, which is obviously the first one. Okay. And this is one word. And it did it. Okay. And we're going to turn that off. Okay. So this is what we're doing. All right. So how do I know? How did I know that BCF was my smaller triangle? Well, I know that because the BC length is associated with 3. Okay, so that would be my scale factor. So I'm going to say BCF and then GLM. Okay. Now, I know that I can do it, write it this way, label it this way, because I'm looking at the order and comparison of the triangles. Okay. So then this tells me that BC, we can go ahead and call it 3. Okay. And then GL, I'm going to call that 5. Okay. So let's think about this. It says select all the other ratios that have the value 3 over 5. So what are they saying? They're saying that oh, okay, if I just barely touch stuff, it comes up. Okay, so what are we really saying? We're saying, okay, so we have the 3 over 5, and if we compared it to other sides, what would it be? Well, you just have to go down the other sides of the triangle now that we've drawn it. It's not a big deal. So I can say 3 over 5 is equal to what? We'll come back to your smaller triangle. C over F, and then go to the corresponding side of the larger one, and that will be LM. Well, that's option B, and it says select all, and there's another one. So then we have 3 over 5. Now we come back to the smaller one and we use the BF. Then we have BF, and then go to the larger one and look at the corresponding side, which is GM. Oh, and the truth is, if you look at the order of the letters up here, let me highlight that. If you're looking at the given, the way they ordered these letters, and see how I underline, and look at what we're getting, you'll see that you really don't need to draw it. But I feel as though. So A works too. So my thought is that if you draw it and work it out, you have a visual. It looks better and it works better to me. Yeah, if I can see it, I believe it. I don't always trust the letters. I don't know why. But anyway, you do it any way you want to, but that's basically the idea there. Okay, number 2. Referring back to question 1, what is the perimeter of BC? Okay, suppose the perimeter of BCF is 36. Okay, so the smaller perimeter is going to be 36. Okay, so that's 36. And so I'm going to write the small one equals 36. And then the larger one. Oh, what is the perimeter of the larger one? Well, that'll be our X. And then we use that setup that we had prior, okay? Right. And we know that our scale factor, our K, equals 3/5. Okay. Now we can scoot up and get this done. Okay. So this is what we have. We have the small one, which is 36 over X equals the 3/5. Notice I'm using the setup where I'm associating the smaller portion, the A is smaller. Remember how we had it in our table. So the 3 is smaller, so I am going to associate that, correspond it to 36. So what do? We just solve now. 3x equals 36 times the 5. Divide by 3, divide by 3, and this is what I need to put in my calculator. 36 times 5. And we can go ahead and divide by 3. It will not cause a order of operations issue because we're just multiplying and dividing. There's no adding and subtracting in there. Okay, equals 60. And that is correct. Option C is what we're looking for. Okay, let's go to 3. Oh, refer back to question 1. Suppose the area of GLM. Oh, that's the larger one. Uh-oh. Let's see here. GLM, yes, that's the larger one. Okay. Oh, and a little note too. Often when you see a value inside a shape, traditionally that implies area. And if it's a prism, that implies volume. But I've noticed that as time has gone on, not everyone uses that. I've seen it true in textbooks. But anyway, that's how I'm going to use it here. Maybe I'm showing my age. Okay, so this tells me that my smaller one, if I could write, and look at how it brought it back. Okay, that's not funny. Okay, let's see if I can turn this on. Give it a second. Come on. Now let's see what my smaller one. Okay, now it works. Interesting. Okay, that is my X. Okay, so what do we need to do here? We need to set it up correctly. Remember, our K is still 3/5, right? So we have 3/5 equal to, okay, our larger area is the 65. So it is associated with the 5. Now, we've forgotten something. Remember, we're dealing with, oh goodness, I'm not sure why I have a technology delay. Okay, there it is. We're dealing with area, and that implies that we must square our K. So if you remember our table, we have to square each of them. So this entire situation will be 9/25 is equal to X over 65, okay, which gives us 25X equals 9 times the 65. Divide both sides by the 25. Okay. Now change colors. And then I know this is what I need to put in my calculator. Okay. Oh, I thought I had the shape off. Well, it's not no harm done, but let's turn off that shape thing. Okay. Now let's put all that in the calculator. Okay. 9 times 65. And again, we do not have an order of operations issue because we're just multiplying and dividing. So we can divide by 25. And 23.4 option D is 100% correct. Okay, let's move on to number 4. Okay, number 4. The ratio of the perimeter of triangle 1 to the perimeter of triangle 2 is 8/3. The altitude to the base of triangle 1 is 5 units more than twice the corresponding altitude to the base of triangle 2. How many units is the altitude of triangle 1? Yes, that is highly annoying. So let's go ahead and illustrate our K value. So you've got triangle 1 over. Oh, I want to turn that off. Okay. Sorry about that. Triangle 2. Okay. Right, I turned it off, and it's still there. Let's cut that out. Okay. Much better. Because once you have it, it's hard to get rid of. Okay. So this is triangle 1. Okay. So 1 is associated with the 8, and 2 is associated with the 3, meaning triangle 2 is actually the smaller triangle. Okay, now I also want to point out that I am not a fan of this term right here, the way they said that. And for our purposes, we are going to call that H for height. That's altitude to base. It makes it seem like you've got some other strange ratio going on, and I've never been a fan of that. So let's go ahead and draw 2 triangles and then work out the rest of the problem. So let me show you what they're saying, okay? All right, let's write. Okay, number 1 is the larger triangle. So let's do number 1. Oh my gosh, if I could draw number 1. Okay. And then here's our height. All right, I'm going to draw an arrow. And this is what they're really saying for number 1. They're saying that if we have the smaller triangle and this height, this altitude here is also the height. And again, use your imagination, okay, about my artwork. Right. Oh, here, I'm trying to get a little bit thicker. There we go. Now this, we are just going to call that H. Okay, we're going to start with number 2, the smaller. Okay, so this is 2. We're going to call triangle number 2, that height is our actual unknown. Okay, now let's read our problem again. Okay, number 1, okay, we're calling this triangle 1 because it's larger. Okay, it's associated over here with this 8. Okay, it says 5 units more than twice the corresponding height. If we say altitude to height is called base, if we say altitude to base is simply the height, okay? All right, so what do we actually have? We have 2 times the height plus 5. Now that I get rid of those words that annoy us and we think it out, now we have something to work with. Now we actually can solve the problem, okay? So now we have a ratio. We have a ratio of the larger one over the smaller one. which is what is set up by our k. So what do we really have? We have 8 over the 3 equals 2h plus the 5 over the 8. Okay? Now we can actually solve for h, but be careful because they're saying, let's go to green, how many units is this? So we have to get our h and then plug h back in to solve for 2h plus 5, okay? So h is not the answer, so remember that. And this type of problem is more like what you're going to see on a practice test. So make sure you read everything, okay? So what do we have? We have 8h equals 3 times 2h plus 15. Okay, divide both sides by h. Both sides by h. Okay, and that will give me, oh, you know what? I don't want to do that. I don't want to do that because I have h. I just realized what I was setting myself up for. Okay. All right. Why do I not want to do that? Well, because I have an H on both sides of my equal, and we need to follow through with the rest of the algebra by distributing. So we need to apply that distribution. Well, that is 6H plus the 15. Now what do we do? Okay, let's think about this. We need to subtract the 6 and bring it over. So minus 6h minus 6h. Okay? Now what do we have? We have 2h equals 15. And then now we divide both sides. So what do we have? H equals 7.5. Okay. Well, remember what I said when we get our value of h, that is not the answer to the problem. So mark out 7.5. And I am very suspicious also. Look at B. B is 15. Well, that's just 2 times 7.5. I'm already saying that B's probably not going to do it. Okay. So what do we really need to get this value? Okay. We need, all right, I'll write it in here. You know what? Let me just change color. Okay. And we need that the altitude, okay, I'm going to call that altitude equals 2 times 7.5 plus 5. And that's multiplied. Okay, if we use parentheses around the multiplication, just to make sure, then we can put this in the calculator. Probably the calculator would do it without the parentheses, but I'm a stickler for that because you never know when your order of operations is going to be a fail. Okay, in parentheses, and then 7.5 parentheses plus 5 equals 20, and that is correct. Option 20. Okay, option D. Okay, let's look at number 5. Go up a little. All right, so it says the ratio of the area. Okay, let's go to our yellow. That's important. Of two similar triangles is 4 over 5. If the perimeter of the smaller triangle is 30, what is the perimeter of the larger triangle to the nearest hundreds? Okay, here's what we're doing. All right, so I'm going to turn this shape thing back on, and I'm going to cross my fingers that it works. Okay, so we have a smaller triangle and a larger triangle. Okay. Okay, and we're going to have to pretend that these are equilateral. And think about what they gave us. They gave us this 30. Oh, forgot that's on. Let me make the other triangle. And once you get it, it doesn't go away. You have to ixnay it. I should know better. Okay, let's do the larger. Okay. All right. Now, and we are going to have to pretend that those are equilateral. They don't quite look like equilateral. Maybe I can make them look like equilateral. And why do I say that? I say that because, there, that's a little better. I say that because we have this 30 inches right here, this guy. So that tells me for the smaller one, that we have got sides equal to 10, 10, and 10. Oh, and that's still on. Oh my gosh, sorry. Okay, let's just leave it like that. Okay, so that tells me that it says the ratio is 4/5. So let's set that up. But we have an issue. It says the area of these similar triangles. This means that 4/5 has been squared. So if we want to apply that perimeter to the edge to the 10 on the side, to go to either way to go from the smaller one to the larger one, or the larger one to the smaller one, it does not matter at all. Okay. So that means I have to take the square root. So I have to take 4/5 square root. That means that the k that I need to apply is actually 2 over square root of 5. Okay. Because we had areas of 4 and 5. Okay. Right. And we are needing perimeter because P equals 30 for the small one. So that perimeter is actually our X. We have no clue what that is. Okay. But not a big deal. We can set it up right now. Okay. Well, what is that 2/5 equal to? Well, the smaller perimeter is 30. And then the larger one would be our X, okay? So now we have, I'm going to scoot over to write this. Now we have 2X equals 30 square roots of 5. Divide both sides by 2. And now we can enter that right here. This is what we put in the calculator to get what we need. Okay, so 32nd radical. If you haven't done this in a while, that's what you push. Okay, now 5. And you need to see how the arrow is blinking underneath the radical. You need to arrow over to the right to get out. Now we can divide by 2 and push enter. And that gives us exactly what we need. And of course, you're going to have to round down, but that's option C. Okay. All right. This is the last question in this video. And once again, I really appreciate you guys watching and putting up with me. I know sometimes that I give you more information than you probably want. Anyway, please share us, like us, and happy testing. Oh, don't forget to subscribe.